Hello and welcome everybody to our answer key video for our first worksheet, potential energy and kinetic energy. All right, your work, your worksheet will look a little bit like this. It'll have all of those wonderful questions. I know you have it already. So what I would like to do is walk through all of these questions with you and all of these answers, and we can see if we can make some sense of this. So for the first problem, let's begin. Number one, a boy lifts a 3 kilogram book from his desk, which is 0.9 meters high, to a bookshelf that is 2.4 meters high. What is the potential energy of the book relative to the desk? So looking at this, we're going to unveil a little bit that what we have so far is that we have the information given to us that the mass is 3 kilograms. The height, initial height is 0.9 meters. And the second height is 2.4 meters. So they actually raised from, oh goodness, from 0.9 meters to 2.4 meters. So we're going from there to there, which means overall we gained, what does anybody know? A height of what overall? What did we gain overall for a height? Correct. 1.5 meters is what we gained for our height. Okay, so that becomes our new equation. Remember everybody that our equation is based off of the fact that we are working on the potential energy and kinetic energy. So the GPE equation is mgh, and the KE equation is 1/2 mv squared. Okay, so let's continue to move on. Ultimately, this is asking us to find the potential energy. We want to find the potential energy. So what you will do is we're looking for that potential energy. Moving on, we know that potential energy equals mgh. And from here, we could then fill in, our answers. 3 times 9.8 times 1.5. That 1.5 was gone from subtracting these two. And we get an answer of 44.1 joules. 44.1 joules is your answer to number one. Okay. All right. Let's move on to our next one, number two. If a 2.30 kilogram brick falls to the ground from a chimney that is 7.5 meters high, what is the change in its potential energy? So again, we're starting with the mass, a 2.3 kilogram brick, right? And then we are going to have a height of 7.5 meters, okay, because it starts 7.5 meters up and then falls down to the ground, and we want to find out what the gravitational potential energy is. So as always, we will move down. GPE equals mgh. Please guys, remember and understand that if we're looking for the change, we know when this object falls down to the bottom and hits the ground, the GPE on the ground is 0. This is where the GP is actually a number. Okay? So I need you guys to understand that by looking for the quote unquote change, right? That's my quote unquote change. Looking for the change, we're really just finding the initial GPE. To do that, we take mgh, we fill in what our mgh is, 2.3 times 9.8 times 7.5. and we get an overall answer of 169.05 joules. 169.05 joules for number 2. All right, let's take a look at number 3. Moving on, let's bring this right up. Number 3, a warehouse worker picks up an 11.4 kilogram box from the floor and sets it on a long 1.5 high table. He then slides the box 0.5 meters across the table and then lowers it back to the floor. What were the changes in the energy of the box, and did the total energy of the box change assuming no friction? So let's take our equations, put this to the side, and let's draw just quickly what this looks like. Here is the box. Here is our table. The box comes up, it's placed on the table, it then moves across, and then comes back down. So, relative to the ground, what is the box's initial height? Correct, 0 meters. Relative to the ground, what is its final height? Correct, 0 meters. So overall, what would be the GPE here? Remember, GPE equals mgh, and if the h is 0, the GPE has to be 0, 0 joules. What is the GPE over here? Again, if h is 0, that's also 0 joules. So overall, is there an energy change? And the answer is no. No energy change overall. So we just actually answered our second question first. But we also want to find what were the individual energy changes. And to do that, we need to look at this step right here, lifting the box up. Okay? Because we know bringing the box back down is going to be the same energy, it's just in a negative direction. Okay, so we're going to find this energy right here. So to do that, let's put back our handy dandy information blocker. We are going to bring down, and we know that the mass is 11.4. We know that the height is 1.5. And we know we're trying to find GPE, which is mgh. We plug in our handy dandy numbers, 11.4 times 9.8 times 1.5, and we get a wonderful number of 167.8, excuse me, 0.58, 167.58 joules. And we already said right here, no, the total energy of the box did not change from start to end. Again, no, the total energy did not change. And we know that from our drawing right here, right? We lift it up, and then all the energy we had was brought back down. All right, excellent job. I will pause for a quick break, and then we will join back up and go over 4 and 5. All right, everybody, we are back. So for 4 and 5, I'd actually like to go through these with you, especially number 5. So let's continue on. Number 4. All right. Number 4, a bike rider approaches a hill at a speed of 9.5 meters per second. The combined mass of the rider and the bike is 90 kilograms. Find the kinetic energy of the rider. Let's do that first. So we know his velocity is 9.5 meters per second. And we know his mass, combined mass, is 90 kilograms. We want to find the kinetic energy. Kinetic energy equals 1/2 mv squared. Remember that square only belongs to the v. 1/2 90 times 9.5 squared. Remember to square this first. Okay, guys? And this will come out to be 4,061.25 joules. So that is our answer for the kinetic energy. But there is a second question to this, and the second question is that the rider coasts up the hill. Please find the height on the hill that the rider will reach. So I'm going to draw a little drawing for you. Here is our hill, like so. And here is our bike with our person, right? And he is going this direction, and he has his velocity, and he's got his mass. We want to find out if he coasts up the hill, what is the overall height that he will reach. Now, I want you to understand this. He is at a height of 0 meters right here when he's on the ground. So his GPE equals 0 joules. However, we just calculated that his KE equals 4,061.25 joules. So looking at this, his total energy, energy total, his mechanical energy is the addition of these two, 4,061.25 joules. All right. If he coasts all the way up to here till he finally reaches the maximum point and he stops rolling, what does his velocity become if he has stopped rolling? Correct. It is 0 meters per second, which now by default, due to the equation 1/2 mv squared, if this is 0, 0 squared is 0, 0 times anything is 0, so that means his KE becomes 0 joules. So think about this for 1 second, and this is what we talked about in the notes. If his total energy down here is 4,061.25, what is his total energy up here? Remember, we can't lose energy. We can't magically make it disappear. So it is also energy total 4,061.25 joules. But his KE has gone down to 0. So what do you think that means about his GPE? That has gone from 0 and has now accounts for all of this. So just by making this connection here, we can now solve for the height he will reach, because we know all the KE initially is now going to equal all the GPE finally. So GPE equals mgh 4061.25 equals the mass 90 times 9.8 times some h. Going through here, we will find that 4061.25 equals 882 times h. Very good. We divide. Very proud of you guys. You're doing all wonderfully. And we find a height of 4.6 meters. That is the height that he will reach. All right, and that is number 4. All right, we now have our final problem, and that is number 5. I'm going to give us a brand new sheet of paper. So let's do number 5 together. All right. So you are on the Bizarro ride at Six Flags New England. The height of the first hill is 80 meters. The car you are in has a mass of 10,000 kilograms. And then there's a bunch of things that we have to calculate. So let's see. So we're at a height of 80 meters. We have a mass of 10,000 kilograms. A wants us, so we're going to do A first. A wants us to calculate the GPE at the height of that first hill, MGH. Okay. 80 times 9.8 times, oh, I'm sorry. I screwed that up. You guys should be yelling at me right now. 10,000 is the mass, 9.8, and 80 is the height. So that means the GPE at the height of the first hill comes out to be 7,840,000 joules. 7,840,000 joules. Okay. Let's go on to B. Just a simple MGH calculation there. B, calculate the kinetic energy of the car at the top of the hill. So I'm going to draw a little drawing up here. So we have our first hill. Okay, so the car is up here right now. Now we're going to assume that the car is not moving, so the velocity becomes 0. The velocity becomes 0. Okay. The mass is still 10,000 because that car is just waiting there to fall over the hill. Okay, so let's find the KE. KE equals 1/2 mv squared, but we just said that our velocity is 0, which means the KE comes out to be 0 joules. All right, nice and easy, right? That wasn't too bad. Let's move on to C. For question number C, calculate the total GPE and KE at the bottom of the hill. All right, guys, we're going to calculate that total GPE and KE at the bottom of the hill. Well, remember from our drawing, this car now has a maximum GPE up there of 7,840,000, and it has a KE of 0. So what is the total energy that this car possesses at its beginning run? Add the GPE and the KE. You're right. The total energy possesses is 7,840,000 joules. That is the total energy. All right. So in looking at C, calculate the total GPE and KE at the bottom of the hill. Well, the total energy here will equal the total energy here. So E total is the same E total down here, but the ratio may be different. The amount of GPE and KE up here may be different than the amount of GPE and KE at the bottom. So at the top, we know it was all GPE and 0 KE. At the bottom, if H is 0, what can you tell me about the GPE? Remember the equation. That's also 0. Very good, guys. Which means all of this energy that was originally GPE has been transformed into KE. And now the KE becomes the 7,840,000 joules. Excellent job, guys. This is all conservation of energy and transfer of energy. Okay, I want you to understand that the total amount of energy that we start with will be the total amount of energy that we end with. No ifs, ands, or buts about it. All right, let's see, number 4. So we are still on number 5. We just finished up C. Now let's do D, question D. Calculate the velocity of the car at the bottom of the hill. Well, that's nice and easy. We're going to take our kinetic energy. KE equals 1/2 mv squared. 7,840,000 equals 1/2 times the mass. We still keep that from the top. V squared. So let's do this math out. We get 7,840,000 equals 5,000 times V squared. We divide by the 5,000. We get V squared as equaling 1,568. Then what do we do to undo the square? Correct, we square root it. And we get V as equaling 39.6 meters per second. Excellent job, guys. Excellent, excellent job. All right, E. Let's move on. Almost done, guys. Almost done. We are on E now. So calculate the GPE and KE of the car when it is 50 meters high. Okay, so we know that this car started off with a total energy of 7,840,000 joules. Now we're asking, well, what's the GPE when the hill is 50 meters? So let's do 10,000 times the 9.8 times the 50. In doing this, we get a GPE that is equal to 4,900,000 joules. But we also want to find out the KE. So think about this. You have a GPE and a KE. Together, these make up the total energy. So if I have the total and I have a part, how do I find the other part? Excellent job. You have to subtract these two. So the KE would equal the energy total minus the GPE, or 7,840,000 minus 4,900,000, and we're going to get a KE that is equal to 2,940,000 joules. And these together will give us our total energy. Again, guys, we're just asking the same question in different ways and trying to get a good understanding of what GPE is and KE is and how they change from form to form. All right, our last problem, we're going to do F, and then we will finish up this video. F is asking, calculate the velocity when it is 50 meters high. Well, we have the KE when we're 50 meters high. So let's just solve that for velocity. So 2,940,000 equals 1/2 times 10,000. We're still keeping the same mass, times v squared. If we go through, 2,940,000 equals 5,000 v squared. We're going to find, need my handy dandy calculator. We will divide these two. So now we have 588 equals v squared. Remember, to undo the square, we need to square root it. And in doing so, we get a velocity of 24.2 meters per second. So guys, I hope this has helped you kind of understand what we're talking about here and how we can arrange our answers. So I hope you guys are well versed in this now. And if you have any questions, please do not hesitate to contact me either through email or Zoom or whatever you need to do. Okay. Again, please pause this. Please go through. Please make sure you have the correct answers. And if there are any questions, please contact me. And I hope you guys have all enjoyed Answer Keys with Fabs. And I will see you guys later on another video. Have a great day. Mr. Fabs out. Peace.